Okay, welcome to another video. In this video we're going to cover the basics of configuring OSPF in a single area on two routers in a very basic network. In this case we have a very basic network here with two routers, 4 switches, and actually 5 different networks. We have the 192.168.1.0 network, the 192.168.2.0 network, the 192.168.3.0 network, the 192.168.4.0 network, and the 192.168.255.0 network. So we have 5 networks, 2 routers, and I have hosts on each network except for this network here, which is a point-to-point network between the 2 routers. In this case, I can come to my PC here and try to ping one of the other hosts on another router. I can ping hosts that are connected, or hosts in networks connected to my same router. So in this case, the 192.168.1.1 network can ping the 192.168.2.0 network because they're connected to the same router. However, if I try to ping the 3 network, I get the destination host unreachable because the router doesn't know how to get to the other side of the network. Now you could create static routes on your routers, which works really well in a very, very small network. But in a larger network, it becomes problematic to try to put static routes on every router in the network, going to every other router in the network. You want to make sure you want to use what's called a dynamic routing protocol. In this case, we're going to be talking about OSPF, open shortest path first, OSPF. This is a very easy protocol to configure. There's a lot of more advanced ways to configure it, but the basic configuration is pretty easy. So in this case, what I'm doing is I'm going to look at my network here. I can see that I have to put some dynamic static routing protocols on 2 routers. I have 2 routers in this network, so I have to be able to configure both routers for OSPF. Let's start with the first router, R1. The first thing I have to do when I configure OSPF is I have to go into config mode. So we're going to go into config T. I'm going to type in router, then we're going to put question mark. Okay, I'm going to use, there's 4 different ones in here: BGP, EIGRP, OSPF, and RIP. We're doing OSPF, so I'm going to type in OSPF. Next thing it wants you to do is put in a process ID. The process ID can be anything that you want, and it doesn't have to be the same on all your routers. It only has to be the same on that one router. Because the reason why you have a process ID is because you can have multiple instances of OSPF running on the same router. In this case, we're just going to use OSPF1. That's fine. Next thing I want to do is I want to configure the router to route for specific, or the routing protocol to route specific networks. So I'm going to use the network keyword, and there is the network keyword right here. I'm going to type in network, and I'm going to hit the question mark. Now it's going to ask me for the network number. This is also the same. This is the same as the network ID. Now I am going to do a specific thing here, because all of my networks, if you look at my network here, all my networks start with 192.168. What I can do is, instead of adding a network for adding a line for each of my networks, the 192.168.1.0, the 192.168.2.0, and the 192.168.255.0 network, what I can do is I can just add the 192.168.0.0 network. Okay, what I'm doing is I'm telling it to add anything that starts with 192.168. And then I'm going to hit my question mark. And the next thing it asks for is a wildcard mask, or OSPF wildcard bits. Wildcard bits are the opposite of a subnet mask. If your subnet mask is 255.255.0.0, your wildcard mask is going to be 0.0.255.255. It is going to be the opposite of a subnet mask. In this case, the reason I have two 255s is because what I'm telling the router is I want the router to treat the first part of here, the 192.168 part right here, as the network, and this is this part right here is basically the wild card. Anything that starts, so that means that anything that starts with 192.168, pick it up and use it I want the routing protocol to pick it up and use it. So I'm going to use that wildcard mask, and we'll get into wildcard masks more when we start doing ACLs. But for this, at this point, just remember, it's the opposite of a subnet mask. And in this case, because I want to do an entire 192.168 network, I'm going to use that 0.0.255.255. Next thing I need to do is put in the area. All OSPF routing protocols need an area 0. It's called the backbone area. because this is such a small network, I'm just going to use one area, and if I'm using one area, it's going to be area 0. So I type in area, then I have to type in the area ID. In this case, I'm going to type in 0. So my area ID is going to be 0, and hit enter. And now I've configured this router R1 to do OSPF. Let me save that. And I'm going to go over and I'm going to do the same thing on router 2. Config T, router, OSPF. Again, we're going to use our process ID. It doesn't have to be the same on either router, but it can be. I tend to use the same one. Again, network 192.168.0.0 with a wildcard mask of 0.0.255.255, area 0. Enter. And end this. Write it. Now, what happens next is my OSPF process will create what's called a neighbor relationship. Right here you can see I have a line here that just showed up. It says OSPF, it says ADJCHG. This is the adjacency change. What it means is the adjacency means the router next to it, there's a process that goes on. It says neighbor, tells me the IP address of the neighbor, tells me where it's coming from, and it says loading to full, loading done. What that means is that this router, what I'm on right now, R2, has talked to its neighbor R1 and has finished finished talking to it, and they have exchanged their routing tables. What that means is if I do a show IP route now, what I get is I get a bunch of routes with the O in front of it, the letter O. O, if you look up here on your table up here at the top, stands for OSPF. So I have 2 OSPF routes in this router. I have the 192.168.1.0 network and the 192.168.2.0 network. Those routes have been added because these 2 routers are now running what's called a dynamic routing protocol, and they have added those routes to the routing table. If I come over here and look at this routing table, I do a show IP route. This one has the 192.168.3.0 network and the 192.168.4.0 network. So it has those networks on there already. I didn't have to configure anything other than those couple of lines for the routing protocol. So now I should be able to ping those pings that failed earlier. I should be able to do that ping now, and it should work because that routing protocol is telling the routers how to get to the other side of the network. Now, one of the nice things about using a dynamic routing protocol is anytime you add additional networks to your or additional LANs to your network, those networks will get automatically added to your routing protocol, and I'll show you that in just a second. Let's go into my router and do config T. We're going to add what's called a loopback interface. I'm going to add a loopback interface, loopback 1. And I brought it up, it's already come up. And what a loopback interface is a loopback interface is basically a virtual interface on a router. I can assign a network to it, I can assign a single IP. In this case, I'm going to use it, I'm going to assign a network to it. So we're going to assign 192.168. Let's do the we already have the 1, 2, 3, 4 network. Let's do the 5 network. 5.1. Well, I forgot to put the IP address. And then we're going to do a subnet mask of 255.255.255.0. And we're going to hit enter. And I'm going to end this and write it. Now, I just added another network on the loopback. It is not a real network. It doesn't have an interface that comes off with a cable. It's just it's what we call a loopback. It's a virtual interface, but it still treats it like a regular interface. And if you look at if you did your show run, you would see the loopback. And here is my loopback interface. Okay, it shows up. I can ping it. I can do all sorts of things. I can do a lot of different things with it. We'll talk more about loopbacks later in another video. But now, if I come over here to this router and I do a show IP route, I should now have that network, and there it is, the 192.168.5.1 or 5.0 network, and I now have that network added to my my routing table, and I didn't have to do anything. All I did was add the network to the router, and because I told the router to use the 192.168.0.0 network, anytime I put a new network in there that has the 192.168 at the beginning, it'll automatically add it to the network. Now, let's say I come over to this router and I add, let's add another loopback on router 2. Let's do L01 on INT, L01 on router 2. And this time we're going to do IP address 10.10.10.1, 255.255.255.0. And I'm going to end it, write it. Now, if I come back over to R1 and I do a show route, let's see if I get that network. I don't have it. The 10 network is not showing up in the R1 router. The reason why is because I have not told the OSPF routing protocol to look for the 10 network. Let's go back and look at our OSPF routing protocol. Here's my OSPF routing protocol configuration. I've only told it to look for the 192.168 network. How do I add the 10 network? What I do is I do a config t router OSPF 1 because I want to go back into the router OSPF 1 instance, and then I type in network. In this case, I'm going to use the 10 network. I'm going to do 10.0.0, 0.0.255.255.255. Again, wildcard mask, the opposite of a subnet mask. The 10 network has a default subnet mask of 10.255.0.0.0. The wildcard mask is the opposite of that, 0.255.255.255. Now I'm going to put this in also in area 0. Let's end this and write it. Now if I come over to router 1 and I do a show IP route, let's see what I have. There it is, right there. The 10.0 network now shows up, or the 10.0 network shows up on my router. And I can actually ping from this computer here, I can ping 10.10.10.1 and I get a reply. So anytime I add a network to my router, the router where the network is added, if the network that I'm adding is already covered under an existing OSPF network statement, it'll automatically add the network. If I'm adding a network that doesn't have an OSPF network statement, I just add the network statement to the OSPF routing protocol. It'll add the route to that network, and then it'll propagate that route throughout all the routers on the network. Makes it much easier to manage a network than it does having to go out and put static routes in all of your routers. So I hope you liked this video. I hope it made sense. If you like the video, please subscribe to my channel, and any new videos that come out, you'll automatically have access to. Thank you.